These are the two equations we're going to be solving right now. You might want to pause, see what you can do on your own, and then play and see how these actually work out. So, solving these equations. Our first one, well, we've got a good bit of simplification to do initially. Clear parentheses, and I'll have 4x plus 4 minus 2x equals, on the right, x plus x is 2x, minus 3 plus 7 is plus 4. On the left, I have like terms, 4x and negative 2x. 4x minus 2x is 2x. I have 2x plus 4 equals 2x plus 4. Move your variables first, so I want to get all my variables either to the left side or the right side. To do that, if I want to move my variables over to the left, I want to get rid of this 2x. It's a positive 2x, so I subtract 2x from both sides. 2x minus 2x is 0, and I'm left with 4 on the left. 2x minus 2x is 0, and I'm left with 4 on the right, and I've lost my variable entirely. So let's move on to the next one and take a look at that. Here, let's see if this one makes more sense. I start in the same way. Clear parentheses, simplify each side. 3x plus 6, distributing the 3, minus 4, equals, distributing the 4, 8x plus 4 minus 5x. Combining like terms, 3x plus 2, I have 6, I owe 4, equals 8x minus 5x, I have 8, I owe 5, 3x plus 4. I have variables on both sides of the equation, so I need to collect my variables all on one side. If I want to get rid of this 3x, it's a positive 3x, so I subtract 3x from both sides. 3x minus 3x, I'm left with 2. 3x minus 3x, I'm left with 4, and my variable is gone again. So, my first problem, I ended up without a variable and a true statement, 4 equals 4. Second problem, I ended up without a variable and a false statement, 2 equals 4. The key here is to remember what you're doing when you're trying to solve an equation. When you're solving an equation, you're trying to find the number or numbers that make that equation true if you substitute it back into the original. For the second one, if you think about this, what number can I plug into the original equation that will make 2 equal 4? Well, 2 equals 4 is never true. Misspelling. So 2 equals 4, I've got a false statement, something that is never true. When I'm solving an equation, I'm trying to find all the numbers that make that equation true. Well, there isn't a single number that's going to make this equation true. This equation is a contradiction. It is not true that 2 equals 4. It is never true that 2 equals 4. Be sure you're answering what the question asks for. The question asks, what numbers work? Well, no numbers work. So we say this equation has no solution. Another way we could write that, if we were using set notation, is everything listed within those sets. We can also write that with a 0 with a slash through it, which is the empty set or the null set. And in computer courses, you'll use a slash through the 0 to distinguish a 0 from the letter O. With math, slashing the 0 means something different, the empty set. So with the first equation, we ended up with a true statement, 4 equals 4. no variables, but something that is always true. So here, whatever number we plug into the original, we're going to get a true statement. This is always true. This is called an identity, something that is always true. The solution set is all real numbers. Pick a number, any number, plug it in, you will get a true statement. You can test this by just picking any two numbers. Let x be 5, plug it in, see that you get a true statement. Let x be -2, plug it in, you'll get a true statement. There are an infinite number of solutions, because any number on the number line then is a solution to this equation. We won't be able to list out all the solutions. The other way we can write this in notation is an R with a double bar. That's how we denote all real numbers, the set of all real numbers. Okay? So, if your variables go away, if you have an identity, a statement that's always true, then any number will make that equation true. If you have a contradiction, 2 equals 4, when your variables are gone, something that is never true, you have no solution. Okay? So again, move your variables first, check if you've got an identity or a contradiction. That'll tell you what your solution set is.